Is the racial distribution for students on work study different from the racial distribution for students not on work study? So we have people on work study, white, black, Hispanic, Asian, other, and people not on work study. So work study is where they give you some money, you know, if you have some financial need. I did work study when I was at college, and when I was away at university, they would give me, because I was on financial aid. My parents didn't have a lot of money to pay for college, so um, they would pay me to like work in. I worked in the library at Cal Poly. I worked in the library for a year. I worked in an office. One of the anyway, you don't care about all my backstory. Anyway, work studies, they pay you money. They kind of help pay for your college bills while you have a job on campus. So I had several different jobs on campus, and they paid me to work on campus. So the question is there anything, is there differences for the different races, the white, black, Hispanic, Asian, other, about how many students get work study or not work study? Is there a racial difference? So, you know, we hear a lot about these kind of things. So how do you know if there's real statistical evidence for this or against it? So this is a test of well, I'll do it right here, homogeneity. How would we know it's a test for homogeneity? What does that mean again? Homo means same, right? Hetero means other. So this word means same, and then geneity is like generations. Same generations. Now it means the races, the white, the black, the Hispanic, Asian. We're wondering, are the percentages the same for the different generations, for the different groups of people? Right? A generation is a group of people. So the white people, the black people, the Hispanic people, the Asian people, the other people, do they have the same percentage that are on work study and not on work study? Or is it different? It certainly looks different, right? Like for the white people, more of them are not on work study. Same thing for the blacks, whereas the other, it's kind of close. So it certainly looks different on the surface of it, but maybe that's just because of luck, right? That's always the question. Maybe that's just random luck and they really are the same. So, you know, if you look at the notes, the assumption, here's the notes. Let me kind of erase some of my scribbling here. Here's the notes. They say row and column are the same as HO, and H1, they do not have the same. So there we go. HO is the same, and H1 not the same. There we go. Test for homogeneity, same generation, same, are the percentages really the same? All right, and you know also this is always the assumption, right? Like in a court of law, they assume innocent. So this is the weak evidence. That's why HO is always the weak evidence option. And then it takes strong evidence, like in a court of law, to convict, evidence beyond a reasonable doubt, strong evidence to go for H1. That's always the case in every hypothesis test. The HO is weak, it's the assumption. H1, to get to H1 requires strong evidence. Otherwise, we just stick with HO if evidence is weak, because that's the assumption. All right, so let's go to our calculator. You know what we're going to do? We're going to put this into our calculator. So to do that, we go second, and we hit the x to the -1 button, which I just kind of messed up there. There we go. Which has matrix above it. Hit second matrix, and then go over to the edit menu and hit enter. And then you put in this matrix. Oh, put in, and you want it to be a 2x4. Hit enter, and then put in the data. It's a 2x4 matrix, because remember, you always go down first. This goes down 2 columns and across 4, right? This is a 2x4 right here. It's down 2 rows and across 4 rows. That's a 2x4 matrix. Hit enter, and then put in your numbers. And then when you're done, hit second and the mode button, which has quit above it. And then hit stat, go over to tests, go down to C, which is the chi-square test, and hit enter, and you'll get your results. All right, I'll show it on my calculator. All right, here we go. Second matrix, go over to edit, hit enter. Mine's a 2x4, 2, enter, 4, enter. There it sets up a 2x4. Just you don't need to clear out the old numbers. Don't worry about it. Just type the new numbers right over the top of the old. It'll be fine. So 70 for me, my numbers 79, 42. Go across the top here. Oh wait, this is a 2x5, isn't it? I forgot. This is a 2x5. My mistake. I'm going to need to quit this. I don't know why I thought that. Let's go back in, try it again. Second matrix. Go over to edit, enter, 2x5, enter. There we go. Try it again. 79, 42, 76, 57, 23. Oh, wait a minute. You got it. You got to hit enter. I'm forgetting to hit enter. I'm totally missing. 79, 42. You got to hit enter each time. I'm forgetting. 76, enter. 57, enter. I was just trying to type them in without hitting enter. Have to hit enter after every entry. And that way it also saves the matrix every time you hit enter. All right, I got it all in there. Then second, quit, the mode button, and then stat, go over to test. You know, a quick way to get there is to go up. You can roll over the top and down to the bottom, and it's closer to the chi-square test. Quicker way to get there. See, hit enter. Those are good. You never need to mess with those. Just hit enter, calculate. There it is. There's the numbers I'm getting. I got chi-squared 1.669. and the p-value 0.79627. All right. Back to my iPad. Okay, so let me change. This should have said 2x5, shouldn't it? 2x5. 2x5. There we go. All right. So what are my numbers? I got a test statistic, which is the chi-square number. Mine was 1.669. It always wants 3 places. 4 places for the p-value. The p-value came out to be 0.7963. And so then the p-value 0.7963. How does that compare to the alpha level? What is the alpha level? There it is, 0.05. That's how strong they want the results, right? They want less than a 5% chance of luck. That's what they're saying. The alpha levels, how strong they want the results. Like we want strong results for COVID vaccine right now, so there's no chance of mistake. We want 5% or below, less than a 5% chance of luck. So mine came out greater. My p-value is greater, much greater. There's a 79% chance that it's just luck. There's a huge chance that any differences, because there are some differences. There's certainly, these are not exactly the same, but the fact is they're just not very different. They're not very different. And so there's a chance, there's a very big chance that could have just happened by luck. There's a 79 p-value, 79.63% chance of luck that any different, that the differences, the chance that the differences are by random luck. That's way too big of a chance. So we don't, this is not strong evidence. So you remember the saying that we always use? If the P is low, the HO must go away, that is. If the P is low, the null must go. Well, our P is not low, it's greater, it's not low, so the null must not go away, which means we're going to keep the null, right? If it's not going away, we're going to keep it. Keep the null, so that means fail to reject the null. We're keeping the null, then you go back up and say, okay, we're keeping the null. You're the winner, null. We're going to keep you. And here you are. We're keeping you. Bye-bye to the H1. So we're keeping the null. And what does the null say? Is the same. And it's weak evidence, right? Weak evidence. Because it was the assumption. It's what we originally said. We assumed that really they were the same. We assumed that the racial distribution was the same. And evidence, in fact, was weak enough that we stuck with our original assumption, that there wasn't strong evidence to make us reject that original assumption. We assumed they're the same, and that is our conclusion because the evidence is weak. So we come down here. Is there sufficient or insufficient? Well, it's insufficient because it's weak. Get rid of these options. It's insufficient to conclude that the racial distribution is not the same. See, it's not insufficient, meaning it's not enough. There's not enough evidence to conclude that they're not the same, right? So we stuck with they are the same. So there we go.
Question.
Question.
So if it's greater, it's always going to be insufficient.
If it's yes.
And then if it's less than, then it's going to be sufficient.
That is right. That is true. Yeah, exactly. Because greater means it's not low. So the null is not going to go. So we're keeping the null, and the null means weak. Yep. So what you're saying is true. Exactly. Does everybody see why we conclude this? There's not enough evidence to say they're not the same. So we're saying they are the same, which is what the null said. They are the same. So there we go.